Welcome to HBOT Journal, a channel dedicated to understanding hyperbaric oxygen therapy through evidence, science, and experience.
Is hyperbaric oxygen therapy safe? I mean, it's the first question anybody asks, right? You're talking about pressure, pure oxygen, and being in an enclosed space. But the answer, well, it isn't a simple yes or no. It's actually all about structure and control. So let's dive in. So here's what we're going to do. We're going to completely deconstruct what safety really means in a medical setting. We're going to build this sort of fortress of control, layer by layer. We'll start with how we even ask the question, then look at the design, the protocols, the monitoring, the crucial human element, and finally, what control actually looks like in the real world. All right, first things first. We have to start by reframing the whole idea of safety, because it's probably not what most of us think it is, especially when you're talking about medicine. And yeah, this is the totally natural starting point. We see the chamber, we hear about the pressure, and our brain immediately jumps to, what's the potential for harm here? And you know what? That potential is absolutely real. But, and this is a big but, this is where we have to pivot. Asking if something is dangerous is kind of a yes or no question in a field that almost never deals in absolutes. Just because a hazard is present doesn't automatically make an entire procedure unsafe. So let's get this distinction really clear. Danger is the raw ingredient. You've got pressure, you've got oxygen. Risk management, that's the recipe. It's the whole system of controls, protocols, and supervision that makes sure those ingredients are handled in a very predictable way. The goal isn't to pretend the danger doesn't exist. The goal is to master it. I mean, think about it. Surgery is by definition controlled injury. Anesthesia involves deliberately altering someone's consciousness. These things are inherently dangerous, but we consider them safe. Why? Because of the massive, complex systems of control built around them. HBOT fits right into that same category. It's not defined by an absence of hazard, but by the overwhelming presence of control. Okay, let's start building that fortress. The very first, most tangible layer of protection is the physical hardware itself. This is the kind of safety you can literally reach out and touch. The intentional design of the chamber.
Just look at how every single one of these features is chosen for predictability. The materials are rated to handle way more force than they'll ever actually face. The fact that it's clear, that's not just so the patient can see out. It's a critical tool for constant monitoring. And for every critical function, you bet there are backup systems. Everything is designed to be clear, simple, and reliable.
This right here, this is the core philosophy. Safety in a system like this doesn't come from one perfect, unbreakable part. It comes from having overlapping, redundant systems. The whole thing is built on the assumption that any single thing could fail. So nothing, and I mean nothing, is ever trusted to work all by itself. Okay, on to our next layer. If the chamber itself is the hardware, then the protocols are the software running on it. These are all the rules and procedures that govern the entire process, and they're designed to do one thing above all else: limit variability. You see, an HBOT session isn't just flipping a switch. It's a very deliberate sequence. The pressure goes up slowly, giving the body time to adapt. It's held at a very specific level for a measured amount of time, and then it's brought down just as gradually. This pacing is totally intentional, because in this kind of environment, speed is the enemy. Speed increases risk. And that brings us to this critical idea. Protocols exist to take improvisation completely off the table. Every session is designed to be consistent, to be repeatable, because any deviation creates uncertainty, and uncertainty is the absolute enemy of safety. In this world, consistency itself is one of the most powerful safety tools we have. So, on top of the hardware and the software, we add the next layer: constant real-time observation. And this isn't just someone casually glancing over. We're talking about active readiness. This analogy is perfect. Passive watching is like a security camera in an empty room. Yeah, it's recording, but nobody's actually watching the monitor. The data is there, but no one's interpreting it. Active readiness, on the other hand, is a trained operator who is not only watching the patient, but is also tracking the gauges, monitoring the time, and is ready to communicate or step in at a moment's notice. And that's the whole point, right? This whole system is proactive. The entire safety plan assumes that things can go wrong. It's built from the ground up to catch the absolute earliest sign of any deviation long before it has a chance to become a problem. It's all about staying ahead of the game. This brings us to the final, and you could argue the most important layer of our fortress: the human commander. This is exactly why, even with all the incredible automation we have today, machines just don't replace trained people. So, a machine can give you this, a number. It's precise. It's subjective. 2.4 atmospheres absolute. It's totally accurate. But on its own, it doesn't really tell you the whole story. And that is why this is so important. A machine sees 2.4 ATM. A trained human supervisor understands what 2.4 ATM means for the specific person inside that chamber at that specific moment. They see if that person looks uncomfortable. They hear if their voice sounds a little strained. They interpret all the subtle human cues that pure data can never, ever capture.
Okay, so we've built our fortress. We have all these layers of control. But now, let's get real for a second. It is absolutely essential to understand that control is an ongoing process. It is not a one-time promise of zero problems.
And what's really important to get about these rules is that they aren't arbitrary. Each one exists specifically to manage a known hazard. For instance, the 100% cotton clothing rule? Oxygen itself doesn't burn, but it makes other things ignite much more easily. Cotton helps reduce the risk of a static spark. Every single rule is a direct response to a known risk. And if you remember one thing from all of this, let it be this. No medical procedure, none, has zero risk. The goal of all these systems isn't to create some magical risk-free environment, because that's just not possible. The goal is to identify all the risks that are avoidable and then systematically reduce them through this dynamic, ongoing process. So let's take one last look at our completed fortress. We have the solid foundation of intentional, physical design. We have the strong walls of strict, repeatable protocols. We have the vigilant sentries doing active monitoring. And finally, we have the commander, providing human supervision and interpreting the context. Each layer holds the others up. So we come all the way back to our original question, is HBOT safe? And the answer is that safe isn't a yes or no sticker you can put on the chamber. Safety is a continuous process of control. It's about how meticulously those inherent dangers are managed through design, through protocol, and through vigilant human supervision. It's about building that fortress where every layer works together to protect the person inside. And with that, it's critical to remember that different designs exist for different contexts, always under appropriate supervision.
To continue learning, explore the HBOT Journal channel.